Anybody want to guess what the problem is? Doesn't know the words. Okay, we have a Bose wave radio here, music system, and it's got this nasty hum. And there's a clue to this, because we can get music in the background, but it's severely distorted. Now, I don't know whether that's because it's on a, it may be because it's not tuned into an active frequency. There's no antenna on this thing here, so okay. Got tuned into my local station here. This is actually coming off my satellite dish. I've just got one of those little modulators that you would use to put your iPod through your car radio, just sitting in my office, and the music from my good old 10-foot satellite dish that's like 30 years old, all it gets is music channels now, so I leave it on the music channel and leave it playing on channel 107.9, and I can tune it in any room in the house. Basically, it covers the yard and a couple houses either side. But as you can hear, we have sound, but it's humming. So that tells me it's probably not the amplifier. It's probably a power supply. It's probably a filter that's gone bad in here. This belongs to a customer, so this is one that I got to fix and give back. I wish it was one that someone said, here, you can have it, take it. Because this is a real nice system. These are a great little system. I'm going to pop this thing apart and we're going to see what's going on with it. And I tell you, here's something that we really don't see enough of, and it's really a shame that we don't see more of this. Made in the USA. I love it. Bose is one of the companies that actually still produces some of their stuff in the States. And I think their equipment is actually top-notch. This stuff is anyway. Some of the Mexican-made stuff, maybe not quite the same quality, but the American-made products are actually pretty good. So after removing the screws, the top cover lifts off with no effort. Here's the sound chamber. Here's our power transformer here, and our amplifier and everything's on this board here. So I'm going to get the speakers out of the way so that we can get a look at the board. So we're going to remove the speakers from the cavity here. Look at the size of the magnets on these things too. They're just massive. That's why the sound quality is so good from these small speakers. They have an incredible amount of throw to them. But I think we need to remove the speakers just to get them out of the way, because the wires here aren't that long. I want to be able to lift this unit out without the wires being trapped at the back here. They're in plugs, but I can't reach the plugs to undo them. I don't have enough clearance. So I think if I remove the speakers from the unit, I should have enough. I should have enough clearance that I can actually lift this unit off. There we go. That's what I need to do. Okay, this is the CD player. The CD player just lifts out of place. It's nicely suspended on little rubber mounts, as you can see. And my amplifier and power supply is back here, so I want to try and get the CD player out of the way. I'm going to take this display off. The fluorescent display board will come off, and that should allow me to tip the speaker cabinet out of the way and work on the board. Okay, now I can tip the speaker cabinet out of the way. Now I have access to all the electronics here. CD player, circuit, CD drive. Here's our amplifier board, our amplifier modules back here. And here's our power supply. And I'm going to pull this board out because I want to look at this power supply. I suspect that maybe we may have a bad filter. It could even be the main filter here. But we're certainly getting AC hum, so I want to get at this board so that I can take a look at it. So we've got the unit disassembled, and I want you to observe something. When I turn on the power, watch the speaker. Notice that? So what we have on here is we have a short in the amplifier module. We've got a DC voltage that's going to the speaker. So inside this amplifier module, it's going to be a stereo module, TDA, something I haven't looked at it yet. But that module is going to be shot. It's outputting a DC voltage. And we can actually measure that. If I take my voltmeter here, we'll just set the voltmeter up so you can see it. And I'll just ground one probe to ground. For that matter, I could even use the speaker ground for that matter, because if we go into ohms side, you'll see that one side of the speaker is probably grounded. Maybe not. It might be. This might be a bi output. It might be a bi amplifier output. It more than likely is, actually, come to think of it. But if I ground, a good source of ground is going to be like the tuner module here, or even maybe even the heat sink. But if I ground one probe, side of probe, to the to a known ground source, which will be the shield for the FM tuner, AM/FM tuner, that'll be grounded. If I take my other probe and we just touch it to the speaker terminal here and I turn it on, you get 7 volts on one side, 0 on the other. So you can imagine that, yeah, putting 7 volts across the speaker, that's going to burn that speaker out pretty quick. So let's just unplug that one speaker that's at fault, and we can test the unit without the speaker plugged in. Now I don't have to worry about blowing the speaker if the speaker isn't already blown. We can test that though, because I can plug it into the other side. So let's just turn the radio on. Now it's not going to sound very good without the cavity. But if I put the speaker into the cavity, it's going to sound a lot better. And as you can hear, the sound is a lot better once I get it into the cavity here. So we know that that speaker is okay. Let's just unplug the speaker here, apply the other speaker into the good side, and just see how it sounds. See if the speaker itself is cooked, because it may be damaged from just being run like that. I don't know how long the owner of it ran it when it was humming. Sounds like the speaker might be okay, actually. Yeah. I think our speaker's okay on this thing, so it's just a matter of it's just going to be a matter of getting the replacement IC. So here's our problem here. It's a TDA 7376. That's a 35 watt times 2 power amplifier for car radio. And it'll do 40 watts into 4 ohms. And here's our block diagram for it. It's shot. I got to get a new one. And that'll get this unit back working. To access the IC, we should first disconnect the flexible cable that connects to the CD player, and then we can remove a couple screws and physically remove this entire board that has our amplifier on it. So we'll remove the screws here. It looks to be probably 3 or 4 screws to take out. Yep, 4 screws. Now this unit can lift out. I've also got the AM antenna that's plugged in over here. And I don't know if that unplugs or not. It may not. I think it doesn't. We just lift the whole antenna out. So now we can see the bottom of the circuit board here. Just check for broken connections. I'm sure the IC itself is toast. Yeah, it doesn't look to be a problem here. it actually looks to be quite well put together. So if you look at this board, this is actually a very well designed and very well built unit. They use a lot of surface mounted components on here, and just generally good quality construction. I don't see any suspect solder connections or anything. Our fault is going to be the IC here is shot. So I'm going to order a new one in, and once we get the new IC, we'll go about changing this one. To make the board a little easier to work on, I'm just going to unplug the transformer so I can get the transformer out of the way. That way I can work on the board by itself. And probably the easiest way to remove this IC is going to be to unscrew the heatsink. So I can remove the IC with the heatsink, because the screw that's going through here, as you can see, this shield is in the way. So we're going to remove the heatsink. I'm going to desolder the old IC using an iron and my desoldering pump. My vacuum tool here will take the solder off the bottom of the board and then remove the heatsink with the chip on it. And then once I get the new part, I can just go about putting it back together. So basically we just go about and heat each of the pins up and activate the pump to take the solder off. And as I thought, this is a bi-amp output, so it's got two amplifiers running out of phase. One for the positive wire of the speaker, one for the negative. You can see that if you look at it right here. Here's the speaker terminals. Here, you can see speaker terminals go to that pin, and these other two speaker terminals go to the two end pins here. So these are the two output pins. Positive and negative here. Sometimes when removing the stubborn lead-free crappy solder, it's easier if you apply some fresh solder, and then the desoldering tool is a little easier to suck it up, because a lot of this lead-free stuff is doesn't flow that easily. So if you can put some good high lead content solder onto the board, it can usually make removing these tough to unsolder pins just a little bit easier. So apply it liberally, get it good and hot, and then get in there with the desolder tool and remove it. Once we've got the IC unsoldered, it should just be a matter of rocking the heatsink back and forth a few times, and the IC should actually come right out of the board if we've got all the pins unsoldered. Oh, I've still got one here that's sticking, so I gotta throw some more heat on one of these pins, and then the whole IC should just come out. And if you have to resort to using solder wick, good idea to dip this in your liquid rosin solder flex just to give it a little more pulling power, so that it can pull up that little bit of solder that's been left behind. These holes are plated on this, so it's a real bitch to get these ICs out, because you got to get all the solder out. It's a double-sided board, but the holes are plated through. So it's a real bitch to get it all out, to get the IC loose. It's a good design. It's just it makes servicing them just a little bit more of a challenge to get the actual components free. And you don't want to wiggle it too much, because you don't want to damage the board. I don't want to damage the plated through connectors here, and I certainly don't want to damage the top side of the board. So it's important to try and get all the solder out, and sometimes the vacuum pumps just don't give you enough suction to get that solder all the way out, and the way to do it is to use solder wick like this and just give it an extra good coat, give it an extra good soaking of liquid rosin, this stuff here, salt rosin flux. Just dip the solder wick in there. and that'll suck up all of the remaining solder. So that lets me see there's only a couple pins here that haven't broken free yet, and I should be able to just put some heat on those few pins and break them free. And then the IC should just come right out. Someone's out for a joyride tonight. That's about 20 times that scooter's been around my block here. It's like somebody keeps going around and around and around the block. And there they go again. Like clockwork. Okay, there we go. We got it out. Now just to go over the board a bit here, just to clean up the connections here, the pins, so that when I get the new part I can just drop it in. So we'll just use some solder work just to clean up the holes here a bit. This is the one that was giving me all the trouble, right there in the middle. And all those holes look to be pretty clean. Shouldn't have a problem putting another IC in there. We'll get some alcohol and we'll clean up the back side of this board here with some rubbing alcohol and get all the excessive flux off of it. So we just clean up the back of the board here with rubbing alcohol, get all the excess rosin off of it. Get the board prepped so that when the new part arrives, all I have to do is pop the new part in and solder it back down. So we're back on the Bose unit here. I got the part in. I had to order it in from DigiKey as none of our local suppliers had the part. Certainly packaged this thing up well. So I'll once again just remove the circuit board that I was working on here. And I just temporarily reattached the heat sink so that I wouldn't lose any of the screws or anything. And of course, being a Bose, they always use these special screws. They're a Torx bit, similar to the security bits used, but these ones don't have that little pin in them, but I'm still using the same Torx bit for this. So now I can remove the defective IC. Yeah, I know someone asked me why I don't use a power driver. Well, as you can see, this is a power driver, but the battery charger died on it. So I have no way of charging up the battery. I don't know even if the battery would hold a charge these days because it hasn't been charged in so long, but you know, I still prefer to remove screws by hand because you don't have to worry about over torquing things when you're doing it by hand. So we'll pop off the bad IC, get the new IC ready to go. Get some heat sink compound on here, spread it over the back of the heat sink here so we have a good uniform coating. seat the new IC in place and replace the screw. Then we can replace the IC along with its heatsink into the circuit board. These are all preformed pins, so they should align with the board and just go directly into the circuit board without too much effort. Just like that. Okay, we've got the IC remounted. Now it's time to solder it back onto the printed circuit board. Alright, don't look too bad. It's one of the advantages to having a big monitor over my workbench is it allows me to inspect my work. Using the camera is basically an inspection tool. We'll also take a look at the top side just to make sure that there's no bridges that are shorts, which there's not, so now we can remount the circuit board and hook up all the cables and make sure that it works. Now I know what some of you might think, that my workspace is not clean and my bench can be sometimes cluttered with tools and stuff, but one thing when I'm working on a piece of equipment is that everything goes in a box, so that everything, and I mean everything, including all the screws and stuff, are all kept with an item that I'm working on, so that I don't have any surprises when I'm reassembling it. For the past couple weeks while I've been waiting for parts, the unit was placed in that box there so that nothing was misplaced on it. So now I've got the unit ready to reassemble. The circuit board just sits in place like that, and the antenna for the AM radio, it was sitting over here. It fits into a bracket over here on this side of the board. It goes in something like that, or is it this way? I think it's this way. These two little rubber standoffs fit down here and hold the AM antenna out of the way, and then there are some screws that hold the circuit board in place, so we'll attach those. And reattach the ribbon cable for the CD player. I think that was one that lifts up. It's not as if it's just a regular connector. Like that. And then the CD player just sits in place like that. And then the speaker assembly goes on top of it. So the speaker assembly sits in place like this. The power transformer attaches down onto the speaker assembly like that, with one screw that connects it. And it actually plugs into the board as well, so let's get the plugs in place. One plug there. The other plug goes in down here. And the speakers plug in down here. Front board attaches back to the front of the unit itself. Front panel goes on with a couple screws, one on each side to hold the front panel in place. Already got one on this side. Okay, ready for testing. Remember that this thing was humming because it didn't know the words. So we got our power cord here. Well, that's a good sign. It says please wait. Okay, the moment of truth. Power. I would say that that's a success. Let's try the CD player. Oh yes, there's no disc in it. I took the disc out. Reading disc. There we go. It's working. Now I gotta remember how to take the CD out of this thing. There we go. Eject. CD stopped. Ejecting. So now we can put the top cover back on it. Let's get these wires out of the way here. They'd actually just get trapped down between the top cover and the speaker enclosure itself, because that's just the way that Bose does it. Take the power cord off the back here. Top cover should just drop on. Just like that. Turn the unit over. Couple screws in the bottom. Power. Got my 12. Please wait. CD. Eject. Go back to radio. That's that buzzing is the light here.
We all just got to.
This channel 107.9 is not going to come in very clear. It's just a it's just an iPod type transmitter. The AC cord operates as an antenna. And it's just coming off my satellite dish. So it's one of those little modulators that has a range of about 50 feet. Also on this setup I have the rest of the unit, which I will plug back in. I have the expansion unit, which sits below it, which is the multi-disc CD player, which plugs in there. Power cord plugs into the back of this unit, and the main power cord then plugs into the changer. And the two units just sit, I guess, like that. They sit on top of each other somehow. I guess something like that. Okay. Let's just check this out here. There should be a couple discs on this thing. Power. CV. Is there no discs in it at all? Okay, so that's how that works. Put the disc in, and it reads it. Don't tell me there's a problem with the separate disc player. For some reason, the external disc player also appears to have an issue. But as you can hear, disc 1 works perfect. So now we have another problem that we have to deal with. One that I was unaware of because I never tested it when I got the unit. It was just given to me as a whole unit to repair, and all in one piece. But it appears that the secondary unit, the disc changer, also has a problem.